Introduction. In your 200 level probability course, you were taught the moment generating functions MGF and means and variances of some distributions were derived using the MGF. In these study sessions, while building upon the knowledge of MGF, you will be opened up to probability generating functions PGF. Learning outcomes for study session 7. At the end of these study sessions, you should be able to define a probability generating function, state the properties of probability generating functions, derive means and variance of some discrete probability distribution. Probability generating function PGF. The probability generating function PGF of a discrete random variable is a power series representation, the generating function of the probability mass function of a random variable x. PGFs are often employed for their succinct description of the sequence of probability P x is equal to I, and to make available the well-developed theory of power series with non-negative coefficients. Definition 1. The probability generating function PGF of a random variable x is defined as gxt is equal to e t raised to power x is equal to summation t raised to power x p x is equal to s, where gxt is defined only when x take values in the non-negative integers. Px is equal to x is the probability mass function of x. The notation gx is usually used to emphasize the dependence on x. Properties of PGF. 1. The probability mass function of x is recovered by taking derivatives of g. P function of k is equal to 2. If x and y have identical PGFs, then they are identically distributed. That is, if there are two random variables x and y, and gx is equal to gy, then fx is equal to fy. 3. The expectation of x is given by if function of x is equal to g raised to power 1 function of 1. Proof. Study the proof below. The variance of x is given by, therefore, variance of x is equal to probability generating functions approach. Probability generating functions approach for deriving means and variances of some discrete distributions. 1. Bernoulli distribution. The probability density function PDF of a Bernoulli distribution is given by mean gx function of t is equal to if function of x, variance is equal to, therefore is equal to, but variance of x is equal to, and variance of x is equal to. This implies that variance is equal to PQ. 2. Binomial distribution. The PDF of a binomial distribution is given by where n is the number of observations, p is the probability of success, q is the probability of failure, x is the random variable, mean is equal to g function of t is equal to g1 function of t is equal to g raised to power 1 into bracket 1 is equal to mean variance is equal to variance of x is equal to NPQ. 3. Poisson distribution. 1. Mean g function of t is equal to lambda squared. 2. Variance is equal to lambda squared plus lambda minus lambda squared is equal to lambda. Summary of study section 7. In these study sessions, you learned about 1. The definition of probability generating function PGF as 2. The properties of probability generating functions. 3. How to derive means and variances of some discrete probability distributions using the PGF approach. This is the end of study section 7. Thanks for listening.